Hey, what's going on, everybody? My name is Tyler. Welcome back to JS Simplified. Today, we're going to be working with Deno's FFI and learn how we can turn our Rust, C, C++, or C# code into DLLs that can be called from Denoland. So let's get started and see what I mean. First things first, let's go ahead and create a new folder in our project, and I'm going to just call it lib. And in here, we're going to have a test.c file. And I'm just going to come up in here and include stdio.h. There we go. Include stdlib.h. And in here creates our int main. There we go. And let's say we want to create a function called void hello world. And we want this function to be callable from Deno. So in this function, I'm just going to go ahead and say hello world from Deno, or from C. There we go. So we have this hello world function, and we want to be able to call this from C. The first things we're going to need to do is we're going to need to convert our C code into a dynamic library. So I am using GCC on Windows. So if you're not using Windows and you're instead using Linux or Mac, the process is going to be somewhat similar. For Linux, you're going to be wanting to create a .so for a shared object file. And on Mac, you'll be wanting to create a dylib file. But for me, I'm going to just go ahead and run gcc-shared-o, and the output's going to be test.dll, and the input is lib/test.c, like so. And this is going to create our test.dll. So with this DLL, we have a function that we want to call from Deno. And Deno actually makes this really, really easy. So I have a main.ts file. And in this project, the only setting in this VS code is Deno enable, and Deno unstable is true. And the only reason I'm doing that is so we have IntelliSense and really nice TypeScript autocomplete. I'm using TypeScript. However, you can do this all in JavaScript. I just want to have the types to help me out a little bit. So let's go ahead and actually create our library. So I'm going to do const lib is equal to, and we're going to open up the Deno namespace and get dl open. Now, DL open takes two parameters. The first one is going to be the path to the DLL that we want to open. So test.dll. Again, if you are on another operating system, this would be .so for Linux and .dylib for Mac. So let's go ahead and say what the symbols are. So if you look, the symbols are the second objects. And what we want is the symbol hello world. So to do that, we can come in here and type hello world is a symbol, and in here we're going to have something like parameters, which is void, or parameters is empty, right? There's no parameters, we're not passing anything into this function, and the results is void, right? So we're not returning anything either. And here we have a hello world function. And one thing you'll notice is it got rid of the string, and that's because that's not needed. But I just wanted to show you that it could do that if you're wondering. So we can come in here and do lib.symbols. And in here we have a list of all of our symbols. So we have hello world, and we can call it like so. And then at the very end, we always close the library, if possible. So we do lib.close if we want to actually close the library like so. So let's go ahead and actually run this, right? We've created our DLL. It's in the same directory as our main.ts. So let's do deno run -- unstable, because this requires the unstable flag, as well as -- allow -ffi. And let's pass in the name of main.ts. And we get hello world from C. So we have called this function from C. And again, we can call it a whole bunch of times. It doesn't matter. So inside of this function, we've created the ability to call functions directly from C. Now, let's step this up and create a function that basically just sleeps on a separate thread for a few seconds. So let's create a function called sleep, and it's going to take in an unsigned int, and this is going to be time. And in here, we're just going to call sleep of time. Now, sleep is undefined right now, right? But if we come up in here and include windows.h, we should be able to call it. And there we go. So I'm going to use the Windows sleep just to kind of quickly demonstrate that we can create code that takes in values as well as is non-blocking. So let's go ahead and recompile this. And in here, we need to now reference our sleep function, right? So sleep is a function that's going to take in a parameter of it's going to take in a U32. Also, usize is the same thing, but we're going to do U32 because this is an unsigned integer, right? And again, the result is still void. And the non-blocking is set to true. And this means we're going to run this on a separate thread. So this is going to sleep for a certain amount of time, right? So if we come down here, and let's just do a quick test, we're going to do const.log before and after. And in here, let's just do lib.symbols.sleep, right? And let's sleep for 2 whole seconds. Now, what you would expect to happen, since by default, let's just look at this. By default, this is going to run top to bottom, right? So let's go ahead and compile this and rerun our code. And we see hello world from C, before, and then if you look again, we see a delay, right? Before and then after. Now, if we want to make this non-blocking, aka, let's say we're doing something on a separate thread, we can also do this, right? Just by changing this, now, hello, before, and after both prints. So we've shown that we can create non-blocking code. We can also await this, right? Because Deno supports top-level await. And we can run hello, before, and after. There we go. So this is how you pass datas into your dynamic library, right? You have to pass the exact type of data. For example, if we were to say this is a U32, but we pass in, let's say, a number that's like 2000.5, we're going to get an error here. And we're going to get an error because we are expecting an unsigned integer. And we passed in a float / a decimal, right? So you got to make sure that you're very careful with the parameters and that they're accurate and true to what this is expecting. Again, if I change this to say I was expecting a Boolean, right, or something like that, and passed in an unsigned int, it would also break like so. So yeah, that is how we can pass data between. Now let's go ahead and get into some more complicated examples where we actually pass data back. So we can also pass values back, right? So we can just pass in, let's say, a int like so. And let's just pass in return 45 or 56, right? Let's just show you that you can pass numbers back. And we can just say let results is equal to this, and then console.log results. And again, the results now is no longer void, it's an I32. And just, oh, it's saying, it wants me to put it as const. There we go. So we need to recompile this now, right? GCC shared, and then let's run it. And we get hello, before, after, and 56. So we can pass data both ways. Now, passing integers and things like that is exciting and all, but let's actually dive into some complex examples where we can pass, say, a string. So I'm going to get rid of this sleep and hello world from here. I'm also going to get rid of them here. And we're going to create a method called sendMessage, which is going to take in a const character pointer array, and it's going to be our message. And all we're going to do is just printf message. We're going to use %s \n and then we're just going to pass in our message. Right? And we want to send a pointer to a string. So again, in C, there's no such thing as strings, so we have to convert it, right? How do we go ahead and do that? So let's actually go ahead and set this up, right? So let's create our lib, and again, we're taking a message or a function called send message. So it's going to be send message. The parameters is where it's interesting, because in here we can pass in a pointer. So we can pass in pointers like that and say result is void, and it's not needed to be non-blocking, right? So you may be wondering, okay, how do I like send a pointer? Can I just do lib.symbols.sendMessage and just say hello world? If you notice, it won't even let me because it says argument of type hello world, right, is not assignable to type unsafe pointer or typed array. And with Deno, you can pass in a typed array or an unsafe pointer. They both kind of get converted to that. So what we can do is we can create a pointer, and I'm just going to call it PTR, and I'm just going to do const PTR is equal to a new text encoder dot encode, and let's just say hello world from Deno. Yeah, there we go. And let's pass this in like so. So we're going to say hello world from Denoland, like so. And we're going to pass it in as the pointer, because again, if you look at the type, it's of type uint array. So it's a typed array. And that's all that matters. When you're sending data as a pointer, you have to send a typed array. So we can compile it and run it, and we get message, hello world from Denoland. Now, I'm going to run this a couple of times, and you already are starting to see some problems here, right? The first time it looked perfectly fine. However, when we ran it again, we saw that we had a whole bunch of these symbols. And if I just kind of run this a few times, right, like so, and just rerun it once, you'll see that we're not getting, like, you know, what we would expect, right? I can run it again. Sometimes it works, sometimes it doesn't. And the reason it is because we're not passing in a null terminator character. If we passed in a \0 to say this is the end of our string, right, then it'll actually work. And the reason is because printf in C is going to look for that null terminator character. So just like in C++ or Rust, you got to make sure that you're adhering to the proper types, right? So if I send in a null terminator or a const char pointer, I need to make sure that I add the null terminator character myself, like that. So if I run this a couple of times, you'll see it seems to work perfectly now. So let's say I also want to send back a string, right? Let's say in here I take in a string and I want to send a string backwards. How can I go about doing that? Well, here it's pretty simple. We can just say we're going to send back a character pointer, right? And let's just return, I'm going to cast it to a pointer. I'm just going to say hello from C. This is a returned value. And it's like that. All right, so we can return a value like this as well. So let's go ahead and do that. And instead of the result being void, it's pointer. So whenever you're passing complex data around, you're going to be using pointers. Now, to take this string, right, we can say const return value is equal to this. Now, one thing you'll notice is return value is not of type string. So I can't just come in here and console.log this return value and expect to get a string. And in fact, we're going to try this and you'll see that it won't work. But let's try it just to see what happens. So we get our message, right? But we don't get a string back. Instead, we get an unsafe pointer. And here is the value of that pointer, right? And the reason is because, again, we're returning a pointer. It doesn't know that this is a string, or it could be a pointer to a custom structure, right? It doesn't know how many bytes this is of what type, so it doesn't know how to convert it. So what we need to do is we need to convert this to a string. So I'm going to do constr is equal to a new Deno dot unsafe pointer view. Sorry, unsafe pointer view. And we're going to pass in our return value, right? Like so. And this is now a pointer view. So it has a few methods and properties on here. One of them is the access to the pointer, but we also have access to getCString. And this is a function that will actually convert this to a string. It's going to look for it's going to look for a null terminated C string. So if it's not null terminated, then it won't work. But we know ours will be. So it's const.log str, like so. Let's recompile the library and recompile here. And we get hello from C. This is a returned value. Beautiful. Yeah, so that looks perfect, right? And if we rerun this, we can see we're able to get the string, pass it back, and vice versa. So that is how you can pass complex pointers to and from Deno. Let's end on one more note, and in the next episode, we're going to be working with custom structures, how you can deal with dynamic memory and things. And that's actually where you get into a lot of really cool examples, like being able to create a wrapper around like a popular C library and use it in Deno. Or in my case, I created a library called Lightbot, which I'm just going to do a quick self-plug, where we can say get the mouse position, select the cursor, click, send keyboard inputs, and such, just using TypeScript. But behind the scenes, I have a whole bunch of C functions, and we can pass data between them. So for this last example, let's go ahead and create a function in C called it's going to return void, and it's going to be gets, let's just call it mouse puzz, like so. And it's going to take in a double, actually we'll take in an int pointer. An unsigned int pointer, and this is going to be our position, like so. Now, this unsigned int pointer is going to be an array of integers. And let's say in here, we want to just basically zero them out, right? So we're going to just do 0, pos of 1 is equal to 0. So we can pass data that we create in Deno and change it in C and then pass it back. So the first part, I'm just going to show you how to zero something out. And then after this, we're also going to use the Windows API to actually get the current mouse position and update this array. So let's go ahead and do that. So in here, we have a function that's going to be mouse puzz, right? So it's mouse puzz. And the parameters are a pointer, right? The results is void. And non-blocking is going to be false, which is what it is by default. So we don't actually need to do anything there. I just wanted to let you know. So here's our mouse position function. And let's say we now want, I'm going to get rid of this right there. And let's create a position. And it's going to be equal to a new uint 32 array. The length is going to be 2. And in here, we're just going to do position of 0 is equal to 45, and position of 1 is going to be equal to 23, like so. So we're going to console log our position, and then we're going to call the mouse position function. So we're going to do lib.symbols.mousePosition and pass in our position, which again, it's going to get converted to a pointer, and here we have our uint32 array. And then at the very end, let's console.log our position as well. So here, our position should be 4523. And when we expect here, we would expect to get 0, 0. So let's go ahead and try this out. Let's first compile our shared library and then run it. And that is exactly what we get. If you notice, we passed in a pointer to a value, and we were able to return that value. So we can also, instead of just passing back a pointer to a value, we can also pass in a pointer and change it in C. So to end this, let's finally test out one thing. So we're going to have a points p, and we're just going to do get mouse, it's mouse, no, it's cursor, cursor. Get cursor position, and it's going to take in a point, and we're just going to pass in a reference to p, like so. And let's get p dot x, and that's what we'll actually set. So here is a Windows function, right? It allows you to pass in a point, which is just a vector that holds an x and a y, and it's going to get our cursor position on the screen. And then it's also not unsigned. Now that I think about it, it is not a int 32. It is like that. There we go. Because it has negative values if we're on our left screen or right screen. So, and instead we'll just do p.x and p.y, like so. So we will have a function called mouse position, which is going to take in an integer pointer. So let me change this here. Integer pointer to length, and it's going to change these values to our current mouse position. So I'm actually just going to get rid of that. And in this console.log, we have our mouse position. And what we can do is I'm just going to wrap this in a set interval, like so. And we are going to run this every 100 milliseconds. So let's go ahead and compile this and run it. And bad resource symbols.mouse position. Okay, so I figured out my error, and it's quite silly. So the reason that this is throwing an error, bad resource ID, is because I closed the library after calling set interval. So yeah, now simply changing that, and you'll see that we are able to get our current mouse position. The reason the X is negative here is simply because I'm on my left monitor. If I move this to the right, you'll notice as it's coming closer and closer, it's getting closer to 0. So yeah, now I'm in my left monitor, and obviously the Y is always going to be positive because I only have 2 monitors and they're horizontal. So yeah, we have now the ability to create and pass data between JavaScript and C. And I hope you found this video useful. If you did, please like, comment, and subscribe. If you want to see more videos regarding this, please let me know, and I would love to make a part 2 where I show you how we can deal with more complex objects that actually have a lifetime outside of a single function call, right? This data, it's only alive as long as it's alive in JavaScript, right? But let's say we wanted to create data on the heap, pass a pointer to that data in JavaScript, and then deal with that data later. And this would be really useful. For example, like OpenGL, like to create like an OpenGL wrapper in Deno, you would need to be able to deal with complex data types like that. So in the next video, if you guys want, I can go ahead and dive into that. Until then, I'll see you guys in the next time. Peace.